Hello students, today we will know the working of architecture of 8085 microprocessor. 8085 microprocessor is of 8-bit. Why this is called 8-bit microprocessor? Or we can say that why different types of microprocessor are termed as 8-bit, 16-bit, 32-bit, 64-bit microprocessor. The reason behind this is that if we will give a long instruction, a long data or a long thing to operate, then this microprocessor will split in the bits like 8-bit, 16-bit, 32-bit and 64-bit microprocessor. 16-bit. So let's proceed with architecture of 8085. Here this is the 8085 microprocessor. Here we have to understand three types of buses first. What are these buses? These buses are used to transfer data or instruction or address from one block to another block in microprocessor system. So what are these three types of system buses? First one is your control bus, second is your data bus and third one is your address bus. Control bus is used to transfer the control signals from one place to another place, one block to another block. Like from time and control signal, we can see that these are the control buses. In red line, this one is control buses, and we have to know that since the 8085 is a digital system base, so all the blocks like this one, interrupt controller, serial input output controller, flag register, ALU, temporary register, accumulator and all must be connected to time and control. Why this is required to control? Because if we will not connect these type of blocks to time and control, then synchronization is not possible and then 8085 will not work properly. So we have to connect all the blocks by time and control block. Second is your data bus. Data bus is used to transfer the data from one place to another or one block to another. And address bus is used to transfer the address to the memory. So let's proceed with a single block. First is, let's start with ALU. Why we have to start with ALU? Because we all are familiar with the arithmetic logic unit section of a CPU. Arithmetic logic unit is used to work on different types of operands to perform different type of mathematical operation, logical operation like and, or, nan, nor and all, and addition, subtraction, multiplication, etc. Then let's proceed with the flag register. So ALU, the result of ALU will be shown by the flag register. Flag register is a register is of 8-bit. So if there is any sign like sign is positive, suppose that we are adding two numbers and then result is 0, then 0 flag will be up. If the result will store parity, even or odd, then this will be flag register. So we can show that the flag register is just like a flag in any system which shows the condition. We can see that sometimes when we pass through a railway station, then we will see that a guard will holding a flag which is showing that whether the signal is red or green. So if the signal is red means we can pass. This is same case at some roads also. Traffic control system also requires some flag signals like red, green and yellow. Similarly, here we can make an analogy with the ALU. Means the result will be ALU will be flagged in a flag register. Five types of flag registers are generally there in 8085, that is sign, 0, auxiliary carry, parity and carry. So let's proceed with the block. This one is accumulator. What is the meaning of accumulator? Accumulator means collecting some data, collecting something at one place. So accumulator is used to store the final result of some functions or some operations, and then then accumulator will be finally transferred to some memory location. We have to store different types of data or final results, but for sometimes we require accumulator. Accumulator is required in some functions like addition and subtraction. For these two operations accumulator must be there. Next is our temporary register. As the name suggests, that temporary register means we have to, if we want to store something for temporary purpose, then this will be stored at temporary register. Now here the things are clear, that what is the meaning of ALU, what is the meaning of flag register, what is the meaning of temporary register, and what is the meaning of accumulator. Next, this is interrupt controller. Generally, we see that sometimes some persons are saying that interrupt means some interruption, something which is which is avoidable or which is disturbing. But in case of 8085, interrupt controller is must. Why this is must? Because suppose that some we are performing some data operation or some operations, and something is very urgent is coming, and then this requires urgent attention of 8085, then interrupt controller is used to handle the urgent attention by 8085. Suppose that some signals are there at interrupt, then this will be passed to 8085 to other blocks, that there is some urgent thing which must be care, and so in 8085 will handle that signal. These have mainly following interrupts, like first is your trap, RST 5.5, RST 6.5, RST 7.5, and here two pins, interrupt and interrupt acknowledgement. Interrupt and interrupt acknowledgement is very important signal in 8085. Why interrupt? Because suppose that some signals are there. Here we can see that the arrow is from outer to inside of the interrupt controller, because suppose there is any other device which have some important signal to pass to the interrupt controller, then this signal will be transferred to interrupt controller, and when 8085 it acknowledge this interrupt signal, then interrupt acknowledgement means suppose that we are sending some letter to some of our friends, and then he will acknowledge us that yes, I received the letter. Similarly, if 8085 find a signal as interrupt, then there is a outer signal which is interrupt acknowledgement signal will be transferred to other device, and these are the interrupts. Trap have highest priority. Highest priority means if there is four types of interrupt here, like trap, RST 5.5, 6.5, 7.5, then trap will be of highest priority. Means suppose that there are four interrupts on interrupt controller, then trap will be served at highest priority, then RST 7.5 will be served, then 6.5 will be served, and then 5.5 will be served. Now, after knowing interrupt controller, let's proceed with serial input output control. What is the meaning of serial input output control? Serial input output control means transferring data serially input to the microprocessor or output to the microprocessor. If this will happen, then serial input output control is used to control the serial input data or serial receiving of the data to 8085, and then if we have to transfer some data serially out, then serial input output control is used to control the serial transmission of data to other peripherals or other devices. Here we can see that this is of 8-bit internal bus. Why this is 8-bit internal bus? Because 8085 handles 8-bit data generally. So this have 8-bit internal bus. Now, after proceeding these sections, yes, interrupt control, this section, serial input output control, let's proceed with the instruction register. But before going to instruction register, let's proceed with these register sections. So here we see that temporary register W and temporary register Z. Generally in some block diagrams this is not shown, but this is very important type of registers. Suppose that we have to store something for temporary purpose, then the register W and register Z are used. Then B and C, BC, these are used as 8-bit register, but generally this is used as BC pair register, BC pair, DE pair, HL pair registers are there. BC pair, why this is BC pair? Because sometimes we require that we have to handle 16-bit data, then the lower bit of data will be stored at this B register and higher will be of C register. But the important thing is that we cannot transfer the data from B to C or C to B. Suppose that we have to transfer some data from register B to C, then what we will do? We will use some other mechanism like let's send data from B to some other register and then from other register to C. We cannot send the data from B to C directly. Yes. Similar case with D and E register, we cannot send the data from D to E. But if we want to handle 16-bit data, then we use DE pair. And HL pair. HL pair are generally called memory pair register. Why this is called memory pair register? Because when we have to handle the memory address, then H and L pair is used and the memory address will be transferred to the HL pair. Now, stack pointer. Stack pointer is a very important concept of 8085 or some other microprocessors and microcontroller. Why stack? Stack means suppose that we have to put some CDs one end on another, or we are putting some books one after another, then this will be called stacking. And stack pointer is a register which points to the stack. Stack means a temporary storage type of things which is used to data from some temporary time. Now, program counter. We will explain the stack pointer in next slide in detail, because stack is a very different type of concept and we have to explain in detail only that what is stack, how it works, what is required to handle the stack, which type of instructions are there to handle the stack. Next is program counter. This is a very important concept in 8085. This register is of 16 bit. Yes, the stack pointer is also of 16 bit and program counter is also of 16 bit register. So what is the need of 16 bit register? Because if we are going to handle a program, then the program counter will point to the next instruction to be fetched, and program counter will put the next instruction which is going to be execute. Suppose that we are starting from 0000 H, that is your 16 bit address. So program counter will initialize with 0000 location, and as we will proceed, the increment will be there like 0000 to 0001, 0002 up to FFFFH. Now increment and decrement latch. Increment and decrement latch is a auxiliary of this program counter. This helps in incrementing the memory address, incrementing the program and all. Now address buffer. Address buffer is used to connect the address of the 8 address lines of 8085 to the other location of memory at some other memory devices. And data address buffer. Yes, important thing is that we have 8-bit address line, 8-bit data line and 16-bit address line. Then we have to multiplex. Here we can see that AD0 to AD7. Why this is AD0 to AD7? Because the data bus is of 8-bit and the address bus will be 16-bit. So here data bus D0 to D7 is there, and here address lines, that is A8 to A15. So we can see that A0 to A7 means 8-bit are here and 8-bit are here. So completing this, we find the 16-bit address lines. Now the next process is instruction register. Instruction register means, suppose that we are handling some instruction from some memory, then this will comes from these address lines, then this will be transferred via this line. But before proceeding with this line, the program counter will be initialized, and the program counter will be initialized by 0000H. Means we can use this these lines, and the data will be entered in this line, address will be entered in this line. This goes to program counter then transfer this via this multiplexer to the 8-bit internal bus, and then the data will come to this instruction register. Instruction register will keep this instruction for some times, and then the instruction decoder will send this instruction, understand this instruction, decode this, and then this will send to the time and control unit. But what is the meaning of instruction register? Instruction register is used to handle the instruction for few times, for some time, and then this will be used to transfer the instruction to the instruction decoder and machine cycle and encoding. Now the data will be instruction will be transferred to the time and control, and then time and control signal block is handling the data. This is very important block of 8085, because this will synchronize all the blocks with each other. So different types of control signals are there at time and control block. First is your X1 and X2. X1 and X2 are two crystal input, because since we know that 8085 will work on some clock frequencies, then X1 and X2 is used to provide the frequency to the 8085. Then clock out is used to transfer some clock out is used to transfer some sorry clock out is used to transfer the clock signal to the outer peripherals. And then this is your ready is used for DMA operations like direct memory access operations. This is used when some other memory device or some other devices use to work with 8085. Then RD will be read signal. When the signal is connected to some memory, then data will be read by the 8085. If we have to write some data to some memory, then write signal is used. This is your ALE, address latch enable. This is very important signal of 8085. And here we can see that AD not to 87. So when this when AD not to 87 is used to address or data, this will be decided by this ALE pin. If this pin is high, then the address line will be used, otherwise the data line will be used. Here S1 and S0, these are select lines of 8085. Next, input, output and memory. Suppose that we have to connect input output lines to some pins or some memory. Then this pin is used as input output lines. RD, WR and input out /M. These three signals combined together and gives better result, better working environment. Suppose that we have to write some data to some memory, then WRM is used. If we have to read some data from the memory, then input output M and RD will be used. And this is hold and hold acknowledgement. Sometimes when we connect 8085 to some other peripherals, then there is some signal which say that 8085 should hold for some times, and then if the signal will be acknowledged by 8085, then hold acknowledgement signal is used, that 8085 received the hold signal. And then these are reset in and reset out. Reset in is a very important signal, because when this signal is applied to 8085, then 8085 goes in reset mode and the program counter will be transferred to the 0000 location or initial condition. And this is your reset out. Reset out is used to transfer reset signal to other peripherals. Now we can see that these all blocks has been explained. Now let's proceed with a simple process how any program is executed in 8085. Suppose that we have some program written on some memory, then this will start from, and suppose that we have to add two numbers, then what we will do, we will write a program and store at some memory. Then initially the address will be transferred to the program counter, then program counter will transfer this program counter, then program counter will take the instruction, then transfer to the this instruction register. Then instruction decoder and machine cycle will generate some signals and transfer signals, different types of signals to different blocks. Now according to the instruction provided, these all blocks, like suppose that we have to add two numbers, then from temporary register the opcode will be transferred to the ALU. This performs some addition. If we have to transfer some data to accumulator, then accumulator will be used, and then addition will be done by ALU. After addition, the final result will be stored at accumulator, and then we find our final results. So thanks for today. We will explain the next things in next lectures. Thank you.